Hi, welcome to the course Inputting Data. In this course, we will discuss how we will get data for our study in R programming. There are various ways of getting data. One is using inbuilt dataset. There are a lot of inbuilt datasets available in R. We can use these inbuilt datasets for study. Some of these datasets are empty cars, iris, tooth growth, etc. To attach any dataset to R, use below command. Attach, it is the name of the function, and then the name of the dataset that you want to attach, like iris, empty cars, or anything. If you want to detach any dataset from R, use below command, detach, and the name of the dataset that you want to detach it. It is same like you were loading the libraries and detaching the libraries. In the previous session, I have explained to you, once any library or any dataset is loaded in memory, it takes and occupies memory. Once you are done with that particular library or the dataset, you should detach it. R has the built-in package called datasets. If you load this package using the function library datasets and list all the datasets available using the data function. If you want to get the help of any specific dataset like iris, you can specify question mark and then the database name. If you want to get the structure of a dataset, like how many rows are there, how many columns are there, what are the different data types or different columns, and etc. So you can use str function and specify the path to that particular, the name, sorry, to that particular data set, and it will give you the structure of it. If you want to load any data set in workspace, just specify data and the name of the data set. It will be loaded in workspace. Let's see how we can do manual data entry. We can enter data by hand in our console. What happens every time we are not dependent and we are not using the data sets that are already available in R. These data sets are just for learning or doing some research on the existing available data sets in R. But if there is any new requirement where we have new data set or we want to build some data, might be data is written over there on a piece of paper, you want to manually enter that data in the system, you can use different ways for that. Over here I am taking a simple example of specifying the heights of the students and the weight of the students. Finally, what I have done is I have created the data frame by specifying these height and weight vectors. It will create a data frame and it will store the value in mydf variable. Finally, once you print the value mydf, it will show you the output something like this table in the right side. So it's all about manual data entry. There are some more functions to it that I will explain in the next slide. Also, I will give you a practical example of all these functions that I have explained to you. Either it is manual data entry or using existing data sets. There is another function called seq. If you want to create some values that are in sequence, like starting from 1 to 40, it will create some values like 1, 5, 10. Because I am specifying by is equal to 5, it will skip by 5. Another function that I can use is scan. Scan takes a series of inputs from the user, and if the user wants to stop giving the input, it will enter 2 times. It will press enter 2 times. When I will give you an example of a scan function, you will better understand it. Another way of getting the data inside R programming is importing from some files. For example, I am having some data inside some CSV files or text files. Then what I can do is I can just use some functions like read.table, specify the name of that file. Read.table, specify the name of that file. It has some attributes to further configure how to read the data. There is a header to that particular Excel sheet or CSV sheet or not. What is the separator in the CSV, like that. So if I want to specify, I can specify and it will behave accordingly. Finally, I can inspect the result by just specifying the name of that particular object and it will print me the result. Let me also show you how we can create very simple bar plots in R. Over here, I am just creating some dummy input and storing in a data frame called df. This data frame has two columns. One is dose, second is length. So in dose, I am specifying there are three values, D0.5, D1 and D2, and length 4.2, 10 and 29.5. What I am doing, I am just loading the library ggplot2 and calling a function called ggplot. Data is equal to df, means I am specifying that my data will be there from this particular data frame. Then AES, it is another function where I specify what will be my x-axis and what will be my y-axis. So dose will be there on the x-axis. If you see on the right side in the PPT or in the slide, you will see there is a diagram. On the bottom there is a dose, it is called x-axis, and then length, it is called y-axis. I have specified that x-axis will be dose, y-axis will be length. Then I will specify by specifying plus geometric bar. It means prepare some bars to show the data. Now let me tell you that this particular ggplot function works exactly the same we do our geometric plotting, because in geometric plotting what we do is we first analyze our data that is already given as a first argument, then we define our x and y axis in that particular piece of paper or some kind of a special paper where I can draw my charts like this or graphs like this. Then once I have decided my x and y axis, I will tell that what kind of chart is to be drawn. So that is my final argument, that is called GOM bar. Instead of GOM bar, we can specify some another functions as well to change the shape of the graph that I will tell you later on. I have done some changes inside this particular graph. I have just added theme minimal. So what it has done, it has given a very good interface, having good colors and having some index like this on the right side. It is called the legend. Okay. Now, what about histogram? A histogram actually represents the frequency of values of a variable. These are bucketed into range like 0 to 10, 10 to 20, 10 to 30, 20 to 30, like that. Histogram is similar to bar, but the difference is that it groups the values into continuous ranges. Like I have given an example, the values between 10 to 20, how many students are there whose age is between 10 to 20, or how many students are there who have got the marks between 10 to 20, how many students are there who have got the marks between 20 and 30, like that. If I want to draw this kind of information and show in a graph, I can use histogram. Here x-axis shows that particular frequency and x-axis shows that particular range, 10 to 20, 20 to 30, 30 to 40, like that, and y-axis shows the frequency in that range, like how many students, that is the frequency, how many students in the range 10 to 20, how many students in the range 20 to 30. If there are 5 students in the range of, in the age of 10 to 20, then I will say that 5 is the frequency and 10 to 20 it is the range. There is an example on how to create a histogram. You just create some values, a vector called V, a set of values inside it. Then I will create the histogram using the hist function. Specify that V is the value. V is containing the value, it's a vector. On the X lab means X axis, the label is weight, color is yellow, the color of the bars, and border is blue. That's it. So what it will do is, it will create a histogram. It will by default take some ranges 0 to 10, 10 to 20. Here it is showing that there are around 2 values between 0 to 10. If you see over here in this collection, you see that 9 and 8, there are 2 values between 0 to 10. So it is showing 0 to 10, that is correct. There is one value between 10 to 20. If you see, there is one value between 10 to 20, and likewise, if you see, it is showing the clear picture in a graphical format. There is another example. There is a air passengers data set that I am using over here. It is an inbuilt data set. The main label of this particular histogram is histogram of air passengers. X label is passengers, border is blue, color is green. X limit is equal to C 100 700, means it will give you the values in the range of 100 to 700 only. Over here, if you see in the bottom, it is only showing the values in the range of 100 to 700, 100 to 200, 200 to 300. So if there is any value below 100, that is not being shown in this particular chart. Okay, here IAS is equal to 1, breaks is equal to 5. Breaks is equal to 5 means there will be 5 different bins that will be created over here. IAS, I will give you the example of LAS later on. I think you understood it, and if you have any query, you can take the help of hist function using question mark hist in R, and it will give you multiple examples and the details of different parameters that are available, including these few variables that I have shown to you in this particular sheet. Thanks a lot. Thanks for joining me in and attending this session. I hope you have enjoyed it. Now, next, I will go through the practical sessions of all these particular slides that I have shown you in this particular session, so that you will have good hands-on and comfortability in these particular sessions. Thanks a lot once again. Have a great day.